Okay, so we were in the middle of solving this problem right here, and then my cat's jumped up onto the cat tower that's holding my iPad up and turned the video off. So we were talking about the series n x to the n over 5 to the n, and we did a little bit of algebra with the ratio test and showed that if x was between -5 and 5, then this would turn out to be a convergent series. And don't you dare come near this cat. Okay, good. And now, well, there's a little bit more terminology that we need now. And we have what's called a ratio of convergence and an interval of convergence. And they're kind of two sides of the same coin. They're different ways of saying the exact same thing. And essentially, if I want to find an interval of convergence, I say that's my interval of convergence, -5 to 5. If I want a ratio of convergence, the ratio of convergence is the ratio of this interval. Meaning, well, let's see, this center is at 0, clearly. So if the center of this interval is 0, which is obvious, then the ratio going left and right is 5. So the ratio of convergence is 5. When you are solving out these power series and determining convergence and divergence, you care about their convergence. Sometimes you're told to find the interval of convergence. Sometimes you're told to find the ratio of convergence. Make sure you answer the correct question. Meaning, if I ask you for the interval of convergence and you give me the ratio, it's going to be wrong, because it means you don't understand what you're doing. If I ask for the ratio and you give me an interval, that's wrong. So make sure you answer the correct question. They're two sides of the same coin. They mean the same thing as long as you understand them. But now then, it kind of gives us a goal and kind of a plan on what we're going to do. Given a power series, use the ratio test to determine convergence or divergence, or in particular, where it will converge. Once you know where it will converge, then find your interval of convergence and your ratio of convergence. And there are a few more tricks that can pop up, but as long as you understand the basic principle and you remember your algebra from 171 on absolute values, then everything actually works out fine as long as you do your algebra correct, and then you can kind of see what's going on at the end. Meaning, suppose we have this one. The series n equals 0 to infinity 1 over n factorial x to the n. I want to determine convergence or divergence. I use the ratio test. So I want the limit as n approaches infinity of the n plus first term, which is x to the n plus 1 over n plus 1 factorial, over the nth term, which is x to the n over n factorial. Again, the absolute values are redundant for the purposes of this right now because it's all positive, but I then get the limit as n approaches infinity of, let's see, x to the n plus 1 over x to the n. That leaves me with an x on top. N plus 1 factorial over n factorial. They're going to flip, and then it will be n factorial on top, n plus 1 factorial on the bottom, and then n factorial over n plus 1 factorial. The n factorial cancels out of the bottom, and we're left with the limit as n approaches infinity of the absolute value of x over n plus 1. Now if I want to take my limit, do the same thing we did last time, pull the x out, and I get the absolute value of x, the limit as n approaches infinity of 1 over n plus 1. And as n approaches infinity, clearly this approaches 0. Which means in this case, the limit is 0 times x, which is still going to be 0. For the last one we did, the x that we chose dictated whether our series would converge or diverge. Here it looks like the x doesn't actually matter. no matter what x I plug in, I always get a limit of 0, so it should always converge. And if we look over here, that actually makes sense. This is still this is x to the n, but this is n factorial, which is the biggest growth we know. So ultimately, the denominator will dominate for any x I pick. It'll be, say if x is 12, 12 to the n over n factorial. That would be exponential over factorial. Factorial will dominate. It'll go to 0. It'll converge. Which means in this case, if I want to find my ratio of convergence or my interval of convergence, what x's does it converge for? Well, every x will give me a limit of 0, so it converges for all x's. So the interval is negative infinity to infinity. The ratio is infinity, which for the purposes of this is completely fine. That just means it converges everywhere. Okay, another example. Suppose we have n factorial x minus 5 to the n. I want to know where it converges or diverges. One thing to keep in mind here, this now is not x to the n, it's x minus 5 to the n, which just means it's in this form, it's centered at 5, which, as a tip to keep in mind when you're solving the problem later on and getting your answer, the other two that we had were centered at 0, which means we found our radius from 0, and the interval we got had a center of 0. Which it has to if we're solving the problem correct. Here, whatever interval of convergence we get, the center has to be at 5. If the center of the interval isn't at 5, that's a problem because this is centered at 5. So little tricks you could do to make sure you're doing all your algebra correct. But we're going to do the exact same thing, the ratio test. The limit as n approaches infinity of the absolute value of the n plus first term, which is n plus 1 factorial times x minus 5 to the n plus 1 all over n factorial times x minus 5 to the n. Here again, dealing with the x's, or no, I'll write it all in one shot, whatever. The limit as n approaches infinity, n plus 1 factorial over n factorial. The n factorials cancel, and I'm left with an n plus 1 on top. X minus 5 to the n plus 1, go away cat, over x minus 5 to the n. N of them cancel, and I'm left with an x minus 5. Now pull the x minus 5 out of my limit, and I get x minus 5 times the limit as n approaches infinity of n plus 1. This limit is clearly infinity. So what does that mean about my convergence? The ratio test says if the limit is less than 1, then the series will converge. This limit is clearly infinity, which I guess means it diverges. But that's not actually true. There is one trick here. For any x that I plug in up there, that series will diverge, except for one of them. This is me doing a dramatic pause to let you ponder it and think about it like I would do in class to see if you can come up with the idea. And the trick is, that will diverge for any x unless x equals 5. Because if x equals 5, this becomes 5 minus 5, which is 0. 0 to the n is 0, and this whole series just becomes constant, 0. There's actually a 1 out in front if you write it out, because if you write it out, when n is 0, you get 0 factorial, which is 1, times 0 to the 0, which don't worry about that. Every other term will just give me 0 here, which means this thing will become 0. So it'll converge. Don't, cat. Okay. Bear with me 1 second as my cat climbs the cat tower. and hopefully does not disturb the video. Okay, good. Stay there. I'm not going to pet you. Okay. So anyway, yes. All that really means is, from a convergence and divergence standpoint, when we have these series, these power series, and we're looking for convergence and divergence, there's three possibilities. Either your radius will be 0, and which is, keep in mind here, your radius is 0 means the only place you get for convergence is the center. Which in this case, using this terminology, is A. So the last one we had, it had a radius of convergence of 0 because it only converged at a point, its center. So its interval of convergence would just be a point, A, because there's no interval that it converges on except the center. The next option, your radius is equal to, we'll say, M, where M is just some number greater than 0. I think the first one we got a radius of 5. And then you'll have an interval of convergence around the center. And your interval of convergence will be the center minus the radius and the center plus the radius. So again, for the first one, I think our center was 0, our radius was 5. So our interval was 0 minus 5, 0 plus 5, negative 5 to 5. The last option, your radius is infinite, and then your interval is negative infinity to infinity. So just kind of keep in mind, make sure you know what question you're being asked and you answer the correct question in the correct way. Meaning, am I looking for the radius? It's either 0, because it only converges at its center. It's some number that I find with the ratio test. And then, or then it's infinity, and the x's don't actually matter. Then I can use those radii to find intervals of convergence. Either the interval isn't an interval, it's just a point, the center, or it's an interval around the center, or it's the entire real line, negative infinity to infinity. We are going to do more with these power series. They're really, really important to what we're doing. And so on Thursday, I'm going to do several more of these videos. I know this is already like almost a half an hour's worth of videos for you to watch for this. But we're going to do more with these because, like I said, the ultimate goal will be to then take functions that we know that are maybe hard to evaluate and see if there's a way to turn them into series, power series, and then once I've turned them into a power series, then determine where they converge. And if I know where they converge, then if I want to find the function evaluated at a point, as long as I make sure the series I generate is centered around the point that I'm trying to estimate, then I can be convinced that my estimate is good. And if that last minute sounds really, really confusing, it's actually supposed to, because that's what we're going into next.